Hi everyone, welcome to today's tutorial where we'll learn how to solve a linear congruence in MATLAB. It might sound a bit intimidating at first, but trust me, it's actually pretty cool and incredibly useful. First, let's clarify what congruence means. Congruence is a relationship between two integers a and b, indicating a minus b is divisible by m. It is expressed in the form a is congruent to b modulo m, where a and b are integers, and m is a positive integer. M is called the modulus of the congruence, and b is called the residue of a mod m. Another way to understand this is that if b is positive and less than m, b represents the remainder when a is divided by m. If b is greater than m, it indicates that a and b have the same remainder when divided by m. So what is a linear congruence? A linear congruence is an equation of the form a times x is congruent to b modulo m, where m does not divide a. Here, x is the unknown variable. Any value of x which satisfies the congruence is called a solution. We should also understand the term incongruent solutions. Incongruent solutions are the integers within the set containing integers from 0 to m-1 that satisfy the congruence. Now, let's discuss some theorems related to this equation. 1. Suppose the GCD of a and m is d. The congruence is solvable if and only if d divides b. 2. If it is solvable, then it has d incongruent solutions of the form x0 plus s times m by d, where s ranges from 0 to d-1, where x0 is the unique solution of the simplified congruence, a by d times x is congruent to b by d modulo m by d, where the GCD of a by d and m by d is 1. So this simplified congruence has one unique solution. Now let's break down the code step by step. We create a function named solveLinearCongruence that accepts 3 inputs and returns 1 output. The inputs are the coefficient a, the residue b, and the modulus m. The output is an array named incongruent_sols. We use an if condition to check whether the modulus m is a positive integer. If it isn't, the error function throws an error and displays the given error message. The MATLAB mod function returns the remainder when dividing a by m. This allows us to check if a is divisible by the modulus m. So using the if condition, we check whether the remainder is 0. If it is, then m divides a, so the error function throws an error and displays the given error message. This check is important because, in the definition of congruence, we always assume that m does not divide a. If m divides a, then the congruence becomes 0 is congruent to b modulo m. Consequently, 2 cases arise. 1. If b is divisible by m, then the condition is trivially satisfied for any x, so there are infinitely many solutions. Or 2. If b is not divisible by m, then the congruence has no solution. The MATLAB GCD function returns the greatest common divisor of a and m, which we store in the variable d. Using an if statement, we test whether the GCD d divides the residue b. If it doesn't, we print that the congruence is not solvable. Otherwise, we print that the congruence is solvable and has d incongruent solutions according to the theorem, and proceed further. Next, we divide a, b, and m by the GCD d to simplify the congruence, since all of these are divisible by the GCD. We store these values in new variables, cap a, cap b, and cap m. In this simplified congruence, the GCD of cap a and cap m is 1, so this congruence has exactly one unique solution. We solve this simplified congruence to find the unique solution, and from it, we obtain the incongruent solutions of our original congruence. We create an empty array named incongruent_sols to store the solutions. As mentioned before, the incongruent solutions belong to the complete system of least residues modulo m, which is essentially the set of integers from 0 to m-1. The for loop will iterate through each element of this set, that is, the index x increments from 0 to m-1. At each iteration, using if statement, we check cap m divides cap times x minus cap b. Since ax is congruent to b, modulo m means m divides ax minus b. If the remainder is 0, we find the unique solution of the simplified congruence and store it in the variable named x0. Now to find the incongruent solutions of the original congruence, we generate a linearly spaced vector named s. The lin space returns a row vector s of d evenly spaced points between 0 and d-1. We use the formula to find the d incongruent solutions. That is, each element of this vector is multiplied by cap m and then added to x0, and stored in the array incongruent_sols. The fprintf function formats and displays the given message. The _DISPA function shows the result of the array incongruent_sols on the screen. Always do remember to terminate the declared function and the for and if statements with the end statement. Finally, we call the function at the beginning of the script and run it. Thanks for watching. If you enjoyed this tutorial, don't forget to like, share, and subscribe for more coding and math content. See you in the next video. This is Tough Nut, signing off. Happy coding.